In this video, we're going to learn how to partition a line segment using construction. So in the first unit, you learned how to partition a segment on a coordinate plane. So we divided a segment into a specific number of parts and then looked at a ratio, found the point that divided it into a specific ratio. In this type of construction, we're going to just look at how do we break a segment into any given number of parts. So we're not going to worry about the ratio here. We're just going to try to get the segment into an equal number of parts. So for the first one here, what we're going to do is we're going to go ahead and we want to get segment AB into 5 equal parts. So what I'm going to do is I'm going to start with my straight edge at A, and I'm just going to draw a segment, really any length. You want it to maybe kind of be close to the length of AB, but it really doesn't matter. So just go ahead and extend or create a segment that goes through point A and kind of goes upward here. And from here, what I'm going to do is I am going to, on that segment that I just constructed, I'm going to draw arcs that create 5 equal parts. So what I'm going to do is I'm going to take my compass and I'm going to open it basically so that I can fit 5 equal sections on here. Worst case scenario, if you can't fit them all, well then you just extend this a little bit. And again, you don't have to spread it evenly between here because we're just kind of making 5 equal sections. So I'm going to go about there for my compass. There's not a specific method for this, as long as you get 5 equal sections. So there's going to be 1 equal section. And the most important part is that once you pick your compass width, that you keep it the same. So there's the second one, third one, fourth, and then fifth. And then just check. Make sure you have 5 sections. So I have 1, 2, 3, 4, 5. So that means my end point is going to go right here. So I'm going to go ahead and just put a letter there just because we're going to refer to it. You don't have to have a letter there, but I'm just going to put a letter there so we can talk about it. So then once you get your 5 equal sections, so really this part I'm not going to worry about anymore. So if you wanted to scribble that out, you could erase it, you could get rid of it, leave it there, doesn't really matter. You're not going to use the rest of this, so you can kind of just cross that off. So then from there, what I'm going to do is I need to basically create a parallelogram so that I have AC as one side, CB as another, and then I'm going to create these other 2 sides. So what we're going to do is take my compass and I'm going to measure the length of CB. Because if this is a parallelogram, well, opposite sides are going to be congruent. So I'm going to copy this distance down here. So go ahead and mark that. So I'm going to use the same color arc here so that you know. So then I'm going to copy that down here. And then what I'm going to do, remember I said I got to make a parallelogram. So I need to know the length of AC so that I could copy it down below, opposite AC basically over here. So I'm going to go ahead and mark that. Anytime you're measuring, you want to mark arcs so that whoever's looking at your paper knows that you measured. So all I did was I took that distance from A to C, and then I just copied it down below here, because remember, I'm trying to get a parallelogram. So now I actually have a parallelogram. If I connect these points, I can call this point D. Again, it doesn't really matter what you call it. You don't even have to call it anything. You just leave it as a point. And now I can go ahead and I can make my parallelogram. So if I connect these 4 points, I'm going to get a parallelogram. In this case, it's looking more like a rectangle. Looks like I have right angles. I don't know if I have right angles. It doesn't really matter, put it that way. All we really care about is that these opposite sides are congruent, which they are because I force them to be by copying those distances. So the whole reason why we're doing that is because we need these lines to be parallel so that we can use properties, stuff we haven't discussed yet. We use properties basically of similar triangles to do what we're doing. So the main thing you got to have is the parallelogram so that you get the parallel sides. And then from there, the other properties are later in the year that we will talk about why that's true. So from here, now that I have my parallelogram, what I need to do is basically break up section DB using the same 5 parts. So we already broke it up. AC is equal to DB, so I'm going to take these 5 parts here, just copy them down below. So in order to copy them, go back and measure those. So I'm going to go ahead, I'm going to measure that. So copying that, I'm going to use the same color so that you know that those match. And I'm just going to copy that down here. And it should end up, with the 5 sections, we should end up at B, because if you start with something that's the same length as AC and you break it up into the same 5 parts, well, it should end up being exactly at point B. Now, it might be off a little bit, because there's always room for some error when you're doing these. Compasses move, your hand might move a little, you might not be exactly in the center of the point. There's a lot of little things that could happen that could cause that last arc not to be perfect. So don't worry about it if it's not 100% perfect, but it should be in the ballpark. So now I have my 5 sections, and notice it matches. So we have my 2 equal sides of 5 sections. The last step here is to go ahead and connect all of those arcs. So now what I'm going to do is I'm going to take my straight edge, make sure you're using a straight edge for this, and I'm going to connect this arc to this arc, and I'm just going to continue doing that. Where these lines are intersecting that original segment, which we haven't really talked about, that original segment in a while, that is creating, so where these lines are intersecting is creating 5 equal parts. So really what we've done is we've created all these little parallelograms, and that's why these parts are going to be guaranteed to be equal to each other, because like I said, it's further properties we haven't discussed yet with similar triangles. So from here, all I'm going to do is just add in points to represent the 5 equal parts. So now if you look at your original segment, there's 1, 2, 3, 4, 5 equal parts that I've just created. So that's the construction. So there's a lot of steps. So let's go ahead and just try another one so you get the hang of it. So down below here, we're going to divide this segment into 4 equal parts. Now you might be thinking that you've already done this. Well, you have. You have divided a segment into 4 equal parts because you've used the perpendicular bisector construction, because it's a multiple of 4. So you could divide this in half. And then what you could do is you could divide those halves in half, and you would end up with 4 equal parts. So you could do it that way, but let's use this new method. So because that only works some of the time with the using the perpendicular bisector. So let's go ahead. We're going to start off with extending that segment through point P. And then we're going to go ahead and take our compass. So once you get that segment, you're going to take your compass and draw 4 equal sections. And again, there's not an exact science to this. It's just try to make 4 equal sections using the segment that's given. So I have, or the segment that you've constructed. So I have 1 section, 2, 3, and 4. And again, if you need to extend it further, you can. You can erase that extra little part if you want. But mainly, you got to have your 4 equal sections. And the 4 equal sections, you set that length. Then everything's going to be based on that. So then from here, once you get your 4 equal parts, now we go ahead, we make our parallelogram. So I'm going to just put an R here on that point so we can name it. And then I'm going to go ahead, I'm going to measure my sides. So from R to Q, because now I'm trying to make a parallelogram. And then I'm copying that because parallelograms, opposite sides are congruent. And I need to measure from R to P. R to P, and then, oops, don't do that. I need to measure from R to P so that I can copy it down here. Because remember, we're trying to get that parallelogram. So now these 4 sides, if I connect them, those are equal. So go ahead and connect those with your straight edge. Well, actually, let me put a point here first. So I'll put an S there. And then you can connect your 4 points. And again, it's just happened to look like a rectangle again, but not guaranteed that these are right angles. They probably aren't. They look like they're a little slanted. Sometimes you might do this and you might get more sides that are just slanted a little bit. It really doesn't make a difference as long as you get those opposite sides are congruent and you have your equal parts that you need. Once you have your parallelogram, then you're going to go back and you're going to measure these distances here. So I'm going to measure those and I'm going to copy those down below. So keeping that. And remember, in a perfect world, this is going to end up being exactly on that other endpoint. And it might be shifted a little because if you're not right in the center of your point, that's going to happen, or just your compass moves a little bit. So I'm lucking out probably because I'm using a computer generated compass, so it's a little bit more accurate. It doesn't move. So I get my 4 equal parts, and then from there, now that we have our 4 equal parts and all these sides are parallel, we go ahead and we draw those lines that, or those segments, I should say, that pass through these other arcs and that are passing through our original segment that we were supposed to partition into the 4 equal parts. So now that I've drawn in these yellow segments, or these gold segments, where they cross the original segment, is going to divide it into 4 equal parts. So these 4 parts are equal to each other. So that's how I partition. So there's your process, is basically you start with partitioning. So, well, first of all, sketch that segment that goes through one of the points. Divide the new segment into however many parts. Draw a parallelogram, so opposite sides have to be congruent. Recopy those 4 equal parts and then just connect the arcs between the 2 segments that you've constructed. So that's the process. It's kind of lengthy, but it's the same thing every time, and that's pretty much, there won't be any like special situations with it.